we're asked to find the coordinates of a stationary point and then determines nature. Stationary points are where dy by dx equals 0. So, how do we find dy by dx? Your function y is x e to the power of x, so x times e to the power of x, product rule. The derivative of x times e to the power of x plus x times the derivative of e to the power of x, which gives me e to the power of x, plus x e to the power of x. It's always useful to factorize, especially when I want to find the stationary points. So stationary points, dy by dx equals 0, e to the power of x equals 0, or x plus 1 equals 0. Now e to the power of x cannot be 0. Remember the graph of y equals e to the power of x? Yes, it can never become 0. Yes, also e to any power is bigger than 0. So here we don't have a solution, therefore our only solution is x equals negative 1. For x equals negative 1, y equals, replace in the function, minus e to the power of minus 1 or minus 1 over e. So the coordinates of P are minus 1 over e. Now how determine the nature of the point? Nature means, is it a maximum or the minimum? Okay, we have two methods. Either we find the second derivative or we look at the sign of the first derivative. I am going to look at the sign of the first derivative, x dy by dx. So at x equals negative 1, dy by dx is 0. If we take a point before negative 1, like negative 1.1, and we look at dy by dx, e to the power of x will be positive, it's always positive. X plus 1 is negative. If you multiply, we get a negative sign, or you can just plug into your calculator. If we take a point after minus 1, like minus 0.9, e to the power of x is again positive. X plus 1 will be positive, so this is positive. Therefore, the slope of the tangent is negative here, so the tangent before minus 1, so the tangent will be with a negative slope or positive slope, so this is a point of minimum, and this is your working in the exam. Move to question 2. The normal to the curve at the point Q meets the x-axis at R and the y-axis at S. So we need the normal to the curve at the point Q. So at Q, coordinates 1e, the slope of the tangent is, replace x by 1 in dy by dx, so we get e times 1 plus 1, so it's 2e. Therefore, the slope of the tangent of the normal, is going to be minus 1 over 2e. So the equation of the normal is y equals minus 1 over 2e plus c. We are going to find the c from knowing that the line passes through the point Q. Okay, here is what we found before. So point Q is on that line. When y is e, x is 1. Therefore c is e plus 1 over 2e. So the equation of the line is y equals minus 1 over 2ex plus e plus 1 over 2e. Meet the x-axis at R. For R, if it's on the x-axis, y equals 0, therefore x equals e plus 1 over 2e over 1 over 2e, giving me 2e squared plus 1 over 1. So R has a coordinates 2e squared plus 1, 0. Okay, now we're going to find the coordinates of S. S is on the y-axis, so for S, x equals 0. Therefore, if we put x equals 0, we get y equals e plus 1 over 2e. So S has the coordinates 0, 2e squared plus 1 over 2e. And now we're asked about the area of the triangle ORS. We learned a new formula for the area of the triangle, which we can use. Area is 1 over 2, and now I start with O, coordinate 0, 0, R, S, and I end up with with O. So the area is, now if I multiply 0, these ones are 0, so I get 1 over 2 brackets 2e squared plus 1 squared over 2e minus 0, 0, 0, so equals 2e squared plus 1 squared over 4e, the area. Another way you could have approach area in this case, imagine the coordinate system, the point R of coordinates 0, 2e squared plus 1, S of coordinates 2e squared plus 1 over 2e, 0. So area of this triangle, it is a right angle triangle. So it's half times the coordinate of R times the y coordinate of R times the x coordinate of S.